Welcome to my channel. Please subscribe. Object model. The object model is one of the fundamental concepts of object-oriented programming, OOP. It is a programming paradigm that is based on the concept of objects, which are instances of classes, and the interaction between them. In the object model, everything in a program is considered to be an object, which has a state and a behavior. This state is represented by the values of its attributes, and its behavior is determined by the methods that are defined for it. The object model provides a way to represent the real world in a program. It allows developers to model real-world objects and their relationships, making it easier to design, develop, and maintain complex software systems. The object model is used in many modern programming languages, including Java, Python, and C. One of the key features of the object model is encapsulation. Encapsulation is the process of hiding the implementation details of an object from the outside world. It allows the object to protect its internal state and behavior from outside interference. This helps to prevent unintended changes to the object state, which can cause unexpected behavior. Another important feature of the object model is inheritance. Inheritance is a mechanism that allows one class to inherit the properties and methods of another class. This allows developers to create new classes that are based on existing ones, making it easier to reuse code and to create more complex software systems. Polymorphism is another key feature of the object model. Polymorphism is the ability of an object to take on many forms. It allows developers to write code that can work with objects of different types, making it easier to create flexible and extensible software systems. Polymorphism is often used in combination with inheritance to create complex class hierarchies. While the object model has many advantages, it also has some disadvantages. One of the main disadvantages is that it can be more complex than other programming paradigms, such as procedural programming. This can make it hard for beginners to learn and understand. Another disadvantage is that it can be slower and less efficient than other paradigms, such as functional programming, which can be a concern for performance-critical applications. In conclusion, the object model is a powerful programming paradigm that is widely used in modern software development. It provides a way to represent the real world in a program, making it easier to design, develop, and maintain complex software systems. While it has its advantages and disadvantages, it remains a popular choice for many developers due to its flexibility and extensibility. Elements of Oopm. Object-oriented programming, OOP, is a programming paradigm that is based on the concept of objects, which can contain data and code to manipulate that data. The fundamental elements of OOP are abstraction, encapsulation, inheritance, and polymorphism. Abstraction refers to the process of focusing on the essential features of an object and ignoring the non-essential details. This helps in simplifying the programming process and making it more manageable. Encapsulation refers to the process of hiding the implementation details of an object and exposing only the necessary interfaces. This helps in preventing unwanted changes to the object's internal state. Inheritance is a mechanism that allows new classes to be based on existing classes. Inheritance allows for the reuse of code and helps in creating a more efficient and maintainable codebase. Polymorphism refers to the ability of an object to take on multiple forms. This allows for greater flexibility in the design of the program and makes it easier to modify and extend. By using these four elements, OOP provides a powerful and flexible programming paradigm that can be used to develop complex and efficient software systems. I/O processing. I/O processing stands for input-output processing, which is an essential aspect of any programming language. Input refers to the data or information that a program receives from the user or an external source, while output refers to the data or information that the program sends back to the user or an external destination. In object-oriented programming, I/O processing involves creating objects and methods that allow for efficient handling of input and output operations. For example, in Java, The scanner class is commonly used for reading input from the user, while the systemoutPrintln method is used for printing output to the console. I/O processing is crucial for developing programs that interact with users or external systems, such as databases or files. Without proper input and output handling, a program may not be able to perform its intended tasks effectively or efficiently. Some common challenges in I/O processing include handling errors or exceptions that may occur during input or output operations, ensuring that the program does not encounter buffer overflow or underflow issues, and optimizing performance for large or complex input or output data. These challenges can be addressed through careful design and testing of input and output methods and objects, as well as through the use of appropriate programming patterns and techniques. Overall, I/O processing is an essential aspect of programming in any language, and understanding the principles and best practices of input and output handling is critical for developing robust, reliable, and efficient software systems.